Okay, so in organic chemistry, you learn about different classes, different types of compounds. For example, you learn about alkenes, alkynes, amines, esters, ethers, and then you learn nomenclature rules associated with those different compounds that come from IUPAC, which is the International Union of Pure and Applied Chemistry. And then you learn some common names. Well, finally, there's another way of classifying certain types of organic compounds, and it's based on the number of carbons that are attached. For example, you might have a primary alkyl chloride. Now, what does that mean? That would mean the chlorine is bound to a carbon atom that's attached to only one other carbon atom. Or you might have a secondary alcohol. What does that mean? That means that your alcohol functional group is attached to a carbon atom that's attached to other carbon atoms. Or you could have a primary amine. Okay, we're going to go through some specific examples of these so that you're clear about what it means. Okay, so the first thing we're going to look at is really what is a primary, secondary, tertiary carbon. So I'm going to draw an alkane structure here. I'm going to go through and label what's considered primary, tertiary, and secondary. Okay? So if we look at this carbon atom here, number 1, is considered a primary carbon atom because it's only attached to one other carbon. Okay, this one other carbon it's attached to is right here. Okay, so let's look at this carbon atom. It's considered secondary because it's attached to two other carbon atoms, attached here and here. So number 2 in blue would be secondary. Okay, so what would the carbon atoms on the end be? What would be number 3 and then number 4? If you're saying a primary, you're exactly correct because they're only attached to one other carbon atom. Let's look at an example of tertiary. Okay, this carbon atom in the center would be considered a tertiary carbon atom. It's attached to 3 other carbon atoms. Okay, so tertiary. T-I-A-R-Y, tertiary. Okay, so let's look and see what happens when maybe you put a chlorine or a bromine or some type of halogen on a structure. Okay, so I'm going to start drawing these structural formulas and also a bond line. So we'll draw both versions. Okay, so if I was to ask you to label each of those chlorine atoms, these 2 compounds, label each of those as either primary, secondary, or tertiary, what would you label them as? Hopefully you recognize that these would be labeled as primary because they are attached to one carbon here that's attached to only one other carbon. Same thing here, attached to one carbon here, it's attached to one other carbon. So we've got to get used to the bond line formula. I know it might look a little abstract at first, but got to get accustomed to it. Okay, so this would be a primary alkyl chloride. Remember, alkyl, that's just a carbon-hydrogen chain. Okay, alkyl groups, carbon-hydrogen chain. So primary alkyl chloride. So the classifications for halogen, or your alkyl chlorides, your alkyl bromides, alkyl fluorides are the same thing. Okay, same system applies. We'll see with amines it's a little bit different, but with all of your halogens, alkyl chlorides, bromides, fluorides, iodides, same type of classification. Okay, so let's look at bond line formula for this compound. Look a little bit like that. So what type of alkyl chloride is this? Is it primary, secondary, tertiary? If you're saying that it's secondary, you're absolutely correct because it's attached to this carbon that's only attached to 2 other carbons. Okay, so this would be secondary. So it's a secondary alkyl chloride. Secondary alkyl chloride. Now to illustrate what I mean by the halogens, the classification is the same as far as primary, secondary, and tertiary is concerned. So if I change the structure a little bit and we put a bromine here instead of a chlorine, still considered secondary. The only thing you would change would be the type of alkyl group it is. It would be a secondary alkyl bromide. Okay. So finally we'll do one more example. Once again, this is important, especially for those of you going on to pre-professional school, those of you going to pharmacy school, when they're talking about drug structure, some of your pharmacy classes, they may refer to as being a secondary amine or having a secondary chloride or bromide on it. So you need to have an understanding of what the terminology means. So just to use another halogen example, instead of chlorine or bromine, have an iodide. So what would this classification be? This would be a tertiary alkyl iodide. Tertiary alkyl iodide. Because once again, it's bound to a carbon atom here that's bonded to three other carbon atoms. Okay, now let's look at alcohols and look at amines. So if you need to write anything down, you may want to pause the video and go ahead and do that because I'm about to start clearing the screen off. So now that you have an idea of what primary, secondary, and tertiary carbons are, alcohol classification is really pretty simple. We'll draw bond line formulas for this compound. This would be example 1, example 2. Go ahead, draw a bond line for it. Then we'll draw the structural formula. Okay, and then we'll have example 3 here. Okay. Go ahead and draw the bond line for it. And so I'll leave that without the structural formula because we've got to get used to bond line. I have to get used to that. Okay, so this first example 1, what type of alcohol is that? They're saying primary, you're exactly correct. This is a primary alcohol. It's attached to one carbon here that's only attached to one other carbon. Same thing here with the bond line. If we go down to example 2, there's a carbon here in the center. It's attached to 2 other carbons. It's attached here, attached there. Okay, so this is this carbon atom. It's attached to this one, It's also attached to that one. So it is secondary. This is a secondary alcohol. Okay, this would be a tertiary alcohol. It's attached to a carbon atom right here in the center. That's attached to 1, 2, 3 other carbon atoms. Okay, so 3 other carbon atoms. So remember with bond line formula, you don't draw in your hydrogens. They're understood that they're there. So each of those carbon atoms I have labeled as 1, 2, and 3 on the third example. Those are CH3 groups. Okay. Last set of organic compounds we want to look at are amines, because their classification is a little bit different. It's based on the number of carbon atoms that is bound to the nitrogen atom in an amine. So say if we had this compound, that would be the bond line formula for it. Okay, so let's look at example 1. This is going to be a primary amine. Primary amine, because it only has one carbon group that's attached to the nitrogen. Okay, so amines are derived from ammonia. So remember Lewis structure for ammonia, NH3. Looks like this. Okay, so we're looking at simply substituting those hydrogen atoms with a carbon chain. So when one hydrogen atom has been substituted, it's a primary amine. 2 hydrogen atoms have been substituted, it's a secondary amine. And finally, we'll do a third example. So this would be a tertiary amine. All 3 hydrogen atoms have been substituted. So we're looking at it for bond line. You'll be showing the methyl groups represented like that. So number 1 is a primary amine, number 2 your secondary amine, and number 3 here is a tertiary amine. And you're looking at the number of carbon groups, alkyl groups that are attached to the nitrogen atom. So then got substituting the hydrogens.